Good day, students. Welcome to math.serve.com. In this clip, we're going to continue our work on integration by use substitution, and we're going to focus our attention on integrals that involves inverse trig functions. All right, let's take a look at question number 10. So for problem 10, we have to find the integral of 2e to the 2x divided by 25 plus e to the 4x. Okay, so before we get started with the evaluation of this indefinite integral, do you recall what the derivative of the inverse tan function is? So what is the derivative of the arctan function? The derivative of the inverse tan function is 1 over 1 plus x squared. Okay? So what does this mean? This simply means if you take the antiderivative of both sides of this equation, you end up with the situation or the formula, which is that the antiderivative of 1 over 1 plus x squared dx is equal to the arctan of x plus c, of course. Okay, so we're going to be taking advantage of this formula to find the value of this integral right here. Okay, so let's take a look at the denominator of this integrand here. You have 1 plus x squared. So we can express this as a square without a problem, but this 25 has to be a 1. Okay, so in order to accomplish that, we will have to factor out 25 from the denominator. And we also have a 2 upstairs here. So let's go ahead and factor out the 2 using the multiplicative rule for integrals. So you take out the 2, and then you have the integral of e to the 2x, that divided by, now let's factor out 25 from the denominator. Remember, when you're factoring out, it is as though you are dividing by that value, okay? So if we factor out 25 from 25, we will be left with 1, because 25 divided by 25 is 1. Now what happens when we factor out 25 from e to the 4x? It's as though we're dividing e to the 4x by 25, right? So we end up with e to the 4x over 25. Okay, so that entire expression dx. Now we're looking more like this denominator right here. We have the 1, but the term that's added to the 1 is a square, so we have to express this as a square, and we can also factor out this 25 right here. So let's go ahead and do that. We'll have 2 over 25 times the integral of e to the 2x divided by, divided by 1 plus e. Now what we're going to do is basically take the square root of these, the numerator and the denominator. If we take the square root of the numerator here, is as though we're dividing the exponent by 2. So we have e to the 2x, and then the square root of 25 is 5. We'll just simply square the square root, and that will give us this term right here. Okay, so e to the 2x squared is e to the 4x, and then 5 to the second power is 25 dx. Okay, all right, now we have a formulation that's similar to this, but we can clearly see that we can carry out a u substitution here. So how do we know if we can do a u substitution? If we take this inner function downstairs here and find the derivative, we'll end up with a multiple of the other function there. All right, so let's go ahead and let me set it up in such a way that you can see it. So I'm going to write this as 2 over 25 times the integral of 1 over 1 plus um, e to the 2x over 5 raised to the second power. Now this e to the 2x dx, I'll put it to the side here, times e to the 2x dx. All right? Okay, now let's see if we can use the u substitution here. We're going to call this inner function here u, so let's say u is e to the 2x over 5. Then when you differentiate both sides, you have, you end up with du equals factorial 1/5. What's the derivative of e to the 2x? The derivative of e to the 2x is e to the 2x, so e to the u, du dx, u is 2x, so the derivative of 2x is simply 2 dx, of course. Okay, so the u is going to be 2 over 5 e to the 2x dx. Now, can we make a substitution here? We already have our u, e to the 2x over 5, but this other portion right here, g prime of x dx, the derivative of the inner function, is not exactly this right here. So what we are going to have to do is resolve this coefficient, which is 2 over 5. To address that, we'll simply multiply both sides of our equation by the reciprocal of 2 over 5, which is 5 over 2. So multiply both sides by 5 over 2. And that cancels out here. And that gives us the du that we desire, which is going to be, what is it going to be? It's going to be 5 over 2 du equals e to the 2x dx. Now that's perfect. Why? Because this matches this portion exactly. So we can make a substitution. With u, we'll use 5 over 2 du for this portion, and then we'll have u for the inner function of this composite function here. Okay, so let's go ahead and carry out our substitution. The integral now becomes 2 over 25 times the indefinite integral of 1 over 1 plus, instead of this quantity square, becomes u square. And then this term, e to the 2x dx, becomes 5 over 2 du. All right? Now we're almost there. Remember, the goal is to get the integrand looking like this right here, 1 over 1 plus x squared. Okay? All right, so to accomplish that, we're going to factor out 5 over 2. So if we factor out 5 over 2, we'll have 5 over 2 times 2 over 25 times the integral of 1 over 1 plus u squared du. This looks much better than what we had before. If you notice, we can carry out some simplification of these two factored out constants here, these multiples. 2 goes here 1, 2 goes here 1, 5 goes here 1, 5 goes here 5 times. Now if you evaluate this integral using this rule that we determined earlier, here the antiderivative of 1 over 1 plus x squared dx is the arctan of x. Okay, so the antiderivative of this expression is simply going to be 1 over 5 times the arctan of u plus c. Now, this is not the final answer. Remember that u, we stated earlier that u should be e to the 2x over 5. That's what u is. So we're going to plug in the value of u back into our antiderivative here, and that should give us the final answer. When we carry out this substitution, we're going to have our answer, which is 1 over 5 times the arctan. Instead of u, we'll have e to the 2x over 5 plus c. All right? And that is your final answer. Thanks so much for taking the time to watch this presentation. We really appreciate it. Feel free to subscribe to our channel for updates to other cool tutorials such as this. If you have any questions or comments that you have about this video or calculus in general, please include it in the comments section below this video. More clips can be found on mathgotserved.com, so go ahead and check that out. Thanks again for watching and have a wonderful day.